Alright, in this video I am really quickly doing the unit circle. I've just sped up a video here, and I actually gave some background on that in a previous video. So it's just, as you're watching, you can just listen. You don't have to like try to write that down as quickly as you're seeing it. But basically, with this unit circle, it looks like a lot in the beginning, and as I'm going through this, all that's happening right now is that everything's just being reflected over a y-axis or an x-axis. There's all these patterns that repeat. And I get all the way around the circle one time, and then all these patterns just continue on over and over again. And so the connection then is when we graph this in a different way, y equals sine of x and y equals cosine of x, you're going to see how those patterns just end up repeating.
Alright, so what I've done here is I've made a little graph, and there should be some things on here that look really familiar. First of all, we got y equals sine of x. We could think about that x being just theta, an angle, right? And then I've got this y-axis here. That's this one, and then this is the x-axis right here, all right? And now what I did is I broke the x-axis scale up into some familiar subdivisions here. So we're going to count in radians by pi over 2. So this is 1 pi over 2. This is 2 pi over 2, which simplifies to pi. 3 pi over 2, 4 pi over 2 simplifies to 2 pi, and then I just kept going. I counted by pi over 2, so that's my scale, right? And I've divided it up nice and even like that. All right, so what we're going to do is we're going to graph y equals sine of x, and what we're going to look at as a resource is the unit circle, right? So remember, my y coordinate on the unit circle, right? So as I go around here, if I'm looking for pi over 2, I'm going to look for the y coordinate, right? So what is sine of pi over 2? Sine of pi over 2 is 1, right? Well, what happens in between there? There's something in between there that's going to be like pi over 4, right? So pi over 4 is going to be square root of 2 over 2. Kind of hard to tell exactly where that is. I can tell you that it does hit 1/2 at some point, but it's going to be before the halfway point, so it's going to be like somewhere over here. So the first part of the graph is going to look like this, right? Then we get over to pi. Right, so what is sine of pi? Sine of pi is all the way over here. So pi radians, the y-coordinate is 0. So we're back to here. Then we go to 3 pi over 2 and we look at the unit circle again. What is the y value at 3 pi over 2? It's negative 1. And then at 2 pi, what is it? It's back to 0. So I don't know if I mentioned that, but we start at 0 for the sine because the y-coordinate at 0 degrees is 0, right? So now we need to draw the graph. So what I don't want to see when you graph these is straight lines. We are not connecting straight lines. They are not straight lines here. It literally is this curve. It is a part of a circle. So it should look like part of a circle. It doesn't have to be super exact, but don't just connect the dots. So it should look something like this, right? You're trying to make it a curve, a nice arc here that comes down. And then I've got to make the underside of a circle here, and then come on back up. Now, that's what a sine curve looks like, all right? It's literally part of these curves here that's connecting these circles in a specific pattern, right? If you broke up those parts of the circle and connected them, that's what you're trying to get. And depending on how much space you give right here, it's going to look bigger or smaller. So note the scale here. We're going to talk about those pieces of these graphs later on with the amplitude, and we're going to talk about the period and the phase shifts and all of those things. But for right now, this is just the basic graph of y equals sine of x. If I were to keep going to 5 pi over 2, as I mentioned before with the unit circle, at this point I'm just repeating functions. So 5 pi over 2 is going to be the same value as pi over 2 because it ends at the same, it's coterminal, right? So 5 pi over 2 is going to be 1, 3 pi is going to be back to 0, 7 pi over 2 is going to be negative 1, and 4 pi is going to be back to 0. So it's going to do the same exact thing again. Right? I'm trying to make it smooth as possible. Okay, so that's y equals sine of x. You might be asking yourself, what about cosine of x? What the heck does that graph look like? We would graph it the same way we would graph y equals sine of x. So cosine of x, y equals cosine of x. What we would do is we'd look in the unit circle. And again, all of this stuff is the same. I counted by pi over 2. So each one of these marks, I'm adding another pi over 2 as it went along. And then my scale on the y-axis goes from 0 to 1. And I marked 1/2 in there, although it won't really show up. So first thing, when x is 0, right, when I have got an x in this case is going to be in radians. So what is the x value here on the unit circle? So again, I'm talking about x in this case being radians, but on here I'm looking at the x value there, which turns out to be 1. So the cosine doesn't start at 0, 0 like sine does. It starts at 1. It starts at 1. So I looked on the unit circle. What happens at 0 radians? Its x coordinate is 1. What happens at pi over 2? Well, at pi over 2, if you look on the unit circle, right, if I've gone pi over 2 radians, my x coordinate is 0. Right? So at pi over 2 here, my x coordinate is 0. And I continue on. At pi, what is my x coordinate? Well, I've gone 180 degrees, so I'm all the way over here at -1. And then at 3 pi over 2, I'm back at 0. And then at 2 pi, I'm all the way back at 1 again. All right, so what does the graph look like? Same idea. Do not just connect these and make it look like a V. That is incorrect. That is not using the knowledge that we're giving you here. So it's not just a straight line. It's part of a circle, right? So you're going to try to draw the part of a circle as best as possible. So there it's concave down. I'm going to switch to concave up at this point. All right, and it's looping back up. And again, they're just all pieces of a circle. This is one part of the circle. Looks like, like the first quadrant, right? All right, so what happens after that? Well, it repeats just like the sine function does. So now over at 5 pi over 2, we're going to get back down to 0, because that's equivalent to pi over 2. At 3 pi, we're going to come all the way down to -1. So let's see how I can draw this smoothly. I'm doing all right. Come back up to 0 for 7 pi over 2. And then 4 pi, we're at 1. So the hidden piece here is use enough room, right? The hidden skill, I guess, is make your scale big enough so that you can get a good looking graph. You can really see it, so that if you want to investigate it, you can do that easier. That's what the cosine, y equals cosine of x looks like.